projector to left camera, projector to right camera. If I want to work with 10 and 20 degree data later, well, faster is using stereo, but safer is to use the projector as well. So, what do? Faster or safer?
Faster.
Faster? Okay, let's do faster. Manual brightness setting, so we don't have to readjust. Intensity will be set automatically, so the first will be a bright slide setting exposure, and then it runs free. I have to choose averaging for noise. Okay, how many acquisitions? Well, we want faster, so we're going to make 2. Important question red is calibration plate. Well, we want to have a certain accuracy, and to have a certain accuracy, you need a calibration plate. Your calibration plate has to be certified. So if you want to track this back, you have to certify it every year to actually certify the whole process of data acquisition. That's what everybody does for industrial systems. You have to certify how accurate you are. You need a common standard to, well, blame somebody if something is not working. So your national authority, each country has one, there's also European authority, or other countries, national standards, back traceability of your calibration tools. So in this case, this was calibrated March, so last month. Has to be done every year. It's the most quality control procedures. And I have to find the number, 1784, and this is the front side. This is the plate with the current and the valid point file. Okay, so I start. No, no, it's a little bit oblique. I'm not high enough. Okay. Yeah. Okay, we have positions. This would be, well, lateral positions. So you move this calibration board in space. You move it in the measurement volume that you want to calibrate. Also take oblique shots. See how that works. I'm a little bit oblique, but I think the whole thing is happy. Okay, now it tells me where to go. Minus 33. So the procedure is, well, you assume that first position is in the center of the volume, and then you start from back to front. You could mix these, you could be a little bit offset, because it's not the exact position, but you want to move within the volume. Plus, minus, well, centimeter, anything will work. And with remote, you can use the big screen to set everything. So minus 22. First slide is always for checking exposure, so I don't have to reset exposure, and then it just goes for the coded points. Plus 11. Well, then always these images pop up. You should be reminded that it's all image-based surveying. It's from 2D to 3D space. So what we do is fancy photogrammetry with fixed base, triangulation, and pattern projection. It works a lot with photography. We talked about exposure, depth of field, tele lenses, wide angle lenses. So there's a lot of photography involved in this. So now we turn it in a 30-degree angle. Calibration board. So not only looking flat at the board. So this is the last position. That is everything correct, things will be good. And for each field of view, you not only need lenses, but you will need a proper calibration board. So this one has two sides, a very small one and a larger one. If you have a very large coverage, then you need a larger calibration board. So here would be, well, this is two sizes larger, that's an L plate. Larger for larger fields of view, and then for the very large ones, you have to move the scanner to cover all the areas because you don't want to have a huge suitcase of 2 by 2 meters maybe. So then you move the scanner to extended positions to do the calibration. So calibration is valid. Visualize results. I want to control what I'm doing. So my result is telling me that each coordinate may look like this, looks like the picture we saw before, so different lines, different settings in space of the calibration board. The alignment deviation from the calibration to the sensor is 3 micrometers, so we are doing really okay. So next point, I have to decide how I'm going to scan. And we separate scanning by the way we do the alignment. So how do you align scan by scan by scan to get to a full picture? So there's contour matching. This is where the user has to click a couple of points to do the individual scan alignment. You can put stickers, index marks, which are recognized automatically, distribution of stickers, and this is one way of automatic alignment. The problem is, well, typically you're not allowed to put any stickers on the objects. Maybe around an object, but not on an object. So we like to scan without stickers, without control points. We have seen the turntable. So you have an alignment, scanner to turntable, and works automatically the alignment. You get all the scans aligned. Well, the next option is you can put your scanner on a robot, if you happen to have a robot. To control several axes of the robot, you have a pre-positioning, you can do the automatic alignment. This is more an industrial solution. The third way is not you move the scanner on something with controlled coordinate system. You move the scanner in space and you put cameras around the scanner on top of the ceiling and you're tracking the scanner. So you get information where the scanner is from tracking cameras. So navi-scan, navigational scanning is also an option. But again, these two options, you need a robot or you need a tracking system. This is really for industrial applications. Or there's some universities who actually build tracking systems, combine systems, so then you need one of these. If you have the regular scanner, typically you get a turntable for automatic rotation, or there's also turn and tilt tables. Otherwise, index marks or contour matching. And the smaller your object gets, the more often we use the contour matching, because it's also difficult to have this small thing move around the center of the rotation table, get close enough and get it in the position we want it. So in this case, and also to show something different, we do the contour alignment. So a project will be contour matching. Make a new project. Let's call it number 2. I already defined one. So the software controls the scanner and also controls the data analysis. So it's one integral part of the system. This is the setup I use: scanner name, with the currently valid calibration. If I use the full template, I can define templates of projects, so the way I want to scan. Just going through it. So, do we want fast capture or precise capture? Well, in this case, let's not go for fast. Let's try to get decent data, make it faster, saying, so we take each image acquisition is acquired 4 times, so we can average out noise effects in the data. So you get better data. The number of captures, you can multiply this even further. This takes a lot of time, but you could go to factor of 4, so you could have 4 by 8, 32 acquisitions to reduce noise a lot. It also means you need 32 times the amount of scanning time for each position. So I think 4 and 1 is a good setting. Stability check, this was on. I don't know who recognized it this morning. The scanner was just standing for 20 seconds. So probably stability check kicked in, saying, well, the ground is not stable enough, I stop scanning, I continue, and I'm not shaking anymore. So we keep that on, because this would be blurred images, sometimes hard to detect. And now we have certain parameters, filters, we keep it standard, data masking. Speed up by using preview. So show me a result, a thinned out result every 3rd pixel, 1/9 of the full resolution is shown for scanning. I see if I have holes somewhere, big holes, but in the background you calculate the full resolution data. It makes scanning much, much faster. And when you're done, that's probably also done with calculating the full resolution data. So to make it faster, use preview. Compression, data compression, so how much surface error do I allow? Keep standard, but even here I can set, give me the highest compression, give me the lowest compression, most data. So here I have to make a judgment saying, well, standard, do I want more or less? And I use stereo data. Processing, these are the filters that you use for each scan, and you can always rerun the data and change all these parameters. Start the scanning. The first thing you see, everything is bright yellow, because, well, the scanner is just looking straight. Scanner has to be somewhere here, and I have to switch on my lasers. Lasers in the center of my giraffe, looking at an angle, so I get the top part, don't get all the lower part, and you also see it live view here, and here you see nicely that, well, the yellowish part is exposed correctly, but the black dots are not exposed correctly. So we need a different exposure setting for yellow. So this would be exposure for yellow. And we will need a second one, say moving, where we go for the black part. I can also use a manual adjustment here. Okay, this is center. Oops. Don't have it here. Sorry. So this area is here for reflection. Oh no, I don't make my test scan. Well, when you work with color, the first thing you should dark areas have fairly long exposure times now. We have 2 different dark areas, so it takes a little bit longer than on the white.